Hey guys, welcome to section 5, chapter 2 of the geometry program. And this section is going to look quite a bit different than our first two sections, but it's really important and we're going to spend a couple of days here practicing these new definitions and a new theorem. So make sure your pencils are ready. Let's get at it. Our first definition, and remember geometry is all about our definitions, are vertical angles. Vertical angles are two angles whose sides form two pairs of opposite rays. And I know that that sounds very confusing, but actually when we draw the picture, hopefully you'll think, oh, that's not really bad at all. So vertical angles here, they share the same vertex and they're opposite sides of these rays. Also, this is important to note, vertical angles are congruent. And if you've not heard that term before, congruent simply means equal. All right, and that's going to be important at the end of this lesson. But vertical angles are simply angles that are opposite each other, that share a common vertex there. Okay. Next up, adjacent angles. Adjacent angles are two coplanar angles with a common side, a common vertex, and no common interior points. And you're probably like, what? Again, I think that you'll soon realize that this isn't so hard. This is an example of two adjacent angles. Adjacent angles, in layman's terms, we kind of say are touching angles that share a vertex here and a common ray. So they share that vertex and a common ray. And then another example might be something like this. Let's do 3 and 4. These are adjacent because they share the same vertex here and they have a common ray. So adjacent angles are touching angles. Maybe that's important to write. They're touching angles. Okay, next up, complementary angles. Complementary angles are two angles that when added together are going to form 90 degrees. Okay, so that one is pretty easy. If you add them together, you get 90. I guess you could separate them out if you wanted to see them this way. Let's say this is 50 degrees and this is 40 degrees. Then these would also be complementary angles. All right, and then finally, supplementary angles. And supplementary angles are going to add to 180. And 180 degrees, it would be good for you, if you don't know this, to know that that's always a straight line. So if they add to a straight line, then they're going to be supplementary. Okay, and then they can go the other way too if you want. We'll do 3 and 4. So angles 3 and 4 are supplementary. Angles 1 and 2 are supplementary. All right, go ahead and finish up those definitions, but I'm going to jump into an example for us. So I drew this picture and I've labeled obviously 4 angles here, and I want to see if we can identify the vertical, adjacent, complementary, and supplementary angles in this picture. So remember that vertical angles are opposite angles that share the same vertex. So here's a vertex. Here would be opposite rays there. So angles 1 and 4 are vertical angles. Similarly, if you look up and down, we have opposite angles here with angles 2 and 3. Those are also vertical angles. Okay, now let's talk about adjacent angles. Remember, adjacent angles are touching angles. So these would be angles like angle 1 and 2. Angles 2 and 4. Angles 4 and 3. and angles 3 and 1. Right? So here they are sharing a vertex and a side, right? Or look like 3 and 4, they're sharing this side and this vertex. All right, remember complementary angles add to 90 degrees. Well, if you notice in my picture, I don't have any symbol like we would look for something like this, right? To add to 90 degrees, or have actual angle measures. And so we don't have any in this picture that we know of. So we're going to skip that one, but we do have several supplementary angles because supplementary angles are going to add to a straight line. And actually, for our purposes, the supplementary angles are going to be the same as the adjacent angles, because if you notice, angle 1 and angle 2, they add to 180 degrees. They form a straight line here. Same with angles 3 and 4. They add to 180. But also look the other direction. 2 and 4 are going to add to 180, and also 1 and 3 will all add to 180. Okay, let's keep going. We got more to practice here. Guys, hang with me. You're doing well. Okay, so let's look at this picture and see if we can identify vertical angles. So the only ones that we can say definitively are angles 5 and angle 2. We know that angle 1 and the measure of angle 3 and 4 together would be probably equivalent, but the only thing that we can say for sure is that angle 5 and angle 2 are vertical angles. Okay, what about adjacent angles? So these are touching with the same side. So angle 1 and angle 2 would be an example. There's going to be lots of them. 2 and 3, 3 and 4, 4 and 5, 5 and 1. Right? Because they have a shared side and the common vertex in the middle. Okay, now what about complementary angles? All right, now we know we have a 90-degree angle here, right? And so it makes most reasonable sense that our complementary angles are going to be angle 3 and angle 4, right? Because this has to add to 90 degrees since it's opposite this guy. Okay, and then what about supplementary angles? So these are two angles that are going to add, just two angles that add to a straight line. So for us, this is going to be angles 1 and angle 2. Notice here. And then also 1 and 5 are going to add to a straight line. Okay, so hopefully that's not too bad, but remember that we can name angles in other ways too. So if the numbers are in the vertices, then that makes our life easier. But sometimes we have to use points that are labeled. And so this is a practice of making sure that you can still identify appropriately your points. So let's answer a couple questions here. So is angle A, B, C, so we're talking about that one. Why does that go away? I don't know why that goes away. That angle and angle D, B, E, are they congruent? This is the congruent sign, if you're unfamiliar with that, if you haven't seen that before. So the question is, are they equal? And remember what we said about vertical angles. So vertical angles are opposite angles, and they're also congruent. So are they congruent here, ABC and DBE? The answer is yes. Okay, now can we name two supplementary angles? So we need angles that are going to add to a straight line. So let's take these guys right here. So that would be angle ABC and angle CBE. This is practice for you about naming your angles. We practiced a little bit earlier. We could do one more. I'll squeeze it in here. Angle CBE and angle EBD are also supplementary angles. All right, and then our angles DBE, so we're talking about this guy, and ABD, now we're talking about this guy right here. Are they adjacent angles? So is this angle, I'll call it 1, and this angle, I'll call it 2. Are they adjacent angles? And the answer is yes. Yes, because they are sharing the same side and the same vertex. Okay, there's one other thing that you're going to do in this section, and it's going to apply these definitions. So you have to be able to identify types of angles and then to be able to do some simple algebra to solve. So if you have a picture like this, hopefully you're starting to catch on the fact that these angles are vertical angles. And vertical angles are congruent, which means if we wanted to solve for x, we could do that by simply setting these two values equal to each other. So x plus 10 is equal to 4x minus 35. And now we can use our basic algebra skills. Remember, we're going to move an x over here, and we're going to get 3x minus 35. And then when I add 35 to this side, I get 45 equals 3x. And if I divide both sides by 3, I get x equals 15. All right, so this is our application. We use the geometry definitions and theorems, and then our basic algebra to solve. Okay, let's do one other one. All right, what kind of angles do you think that these angles are? Hopefully you will say complementary angles. And complementary angles add to 90 degrees. So if I take 5x and I add 35, then I get 90. And now I have a simple two-step equation. So if I subtract 35, I'm going to get 55, and if I divide by 5, I get x equals 11. All right, that's it. Like I said, we're going to spend a couple days practicing this skill, but go ahead and finish up your notes, read through the examples, and begin your assignment.